Hello everyone, and welcome to day 7 of the CAS Virtual Showcase 2021. And in this session we're going to be exploring artificial intelligence with the wonderful team from Apps for Good that are with me here today. So I'm really lucky to have Natalie and Donna, who are going to take you through Apps for Good and some of the wonderful experiences your students can have with artificial intelligence in the classroom. Those who don't know me, my name is Pete Marshman and I'm an outreach manager for CAS. And I'm going to be keeping an eye on the questions as we go through the session. So if you've got any questions, you can pop them into the question box. And if you can't see the question box, there's a little orange rectangle with an arrow. If you click on that, it will expand your panel and you can then type in any questions. And I will come to the team here with those questions as they come in, or we'll leave some and towards the end. I will be sort of making a note of any kind of comments to feedback to both Natalie and Donna as the session continues. Please don't forget to use the hashtag CAS Virtual 21 as we run through the session. And please remember that you are in listen only mode. I'm going to start off just making an introduction, and Natalie's going to kick us off to start with. So Natalie's the Chief Operating Officer at Apps for Good. She joined in January 2013 as Education Outreach and Development Coordinator. She's been a keen player in the success of Apps for Good, particularly supporting the rollout, growth and reach of the charity. And later on we're going to come to Donna, who joined Apps for Good in July 2015. She's worked previously at HSBC for 13 years, including roles being a project manager, systems analyst, and various roles in programming. She's also a subject leader previously in computing, and 5 years for 5 years prior to joining Apps for Good. So I think with that information started off, I'd be delighted to get this session started, and I'm going to hand straight over to Natalie, who's going to kick us off for this session. Over to you.
Brilliant, thanks Pete. Yeah, hi everybody, welcome. So, oh, can you guys still see my screen? Have you lost me? There we go.
I can see you fine.
Yeah, perfect. Cool. Yeah, so welcome everybody. Thanks so much for joining this afternoon. I know it's probably already felt like a long day and a long week and everyone's on the countdown to the summer holidays or maybe the England match. But as Pete said, today we're going to talk to you a bit about Apps for Good, who we are, what we do, and then more importantly, our machine learning course. So I'm going to kick off with a bit of a general intro and then hand over to Donna for more detail on our machine learning course. So at Apps for Good, we are an education technology charity. We've been operating in the UK and internationally for 11 years now, working with schools and colleges to upskill teachers to go back into the classroom to deliver our content and courses to their students. We work with primary, secondary and FE, but secondary Key Stage 3 is probably our sweetest spot. It's where most schools tend to deliver our content, and it can be delivered in a whole range of ways, and I'll go into a bit more detail on that. In terms of, I guess, why we set up as a charity all those years ago, and our overarching mission is we want to empower young people to use technology to solve everyday problems that they care about. So the idea is that students will work in teams. They will think of a problem in their day-to-day life in their local community that they would like to solve with the use of technology, and then they go on to essentially replicate the model that many startup companies would. So they'll go through the product life cycle. So they start with their problem, they do that idea generation and screening, they do some scoping, so things like user research and market research to really validate if their idea is a good one and is actually going to help people. They then go on to do some product development, so starting to actually build a prototype of that product, and that can be extremely light touched, paper-based, all the way through to kind of fully developing a product. And they also go on to learn those kind of marketing and communications and confidence skills to be able to pitch their product as well. So we don't just want young people that have created a product, but we want people that can go on to kind of market that and talk about that as well. So our approach, we have 4 key pillars to everything we do at Apps for Good. It's worth saying as well at this point that everything we offer for schools is completely free. So we are a charity funded by corporate partners, which allows us to offer everything to the schools that we work with completely free of charge. So all of our courses and everything we do touches on these 4 key pillars. One of them, tech within a context. So we really believe in showing how technology can really be used to apply to solve a problem that people care about. So not just learning to code because you've been told you need to learn to code, but learning to code to solve a problem that matters to you. Then student-driven learning is really essential to everything we do at Apps for Good. So we want young people to really take a lead in the classroom. That's why we often ask our teachers not to set a theme, but for the young people to really have the freedom to solve a problem that they are really passionate about, because they're more likely to see that through. We want young people to feel like they are being listened to and kind of taken seriously. We then look at transforming teaching as one of our pillars. So we really want to work with schools and make sure that what we're offering helps to make a difference, I guess, to young people, that we are upskilling teachers so they feel more confident to deliver a potentially different kind of pedagogy for something they're used to doing. But what we do does also kind of map to the curriculum. So we are very aware that as teachers, you'll have kind of boxes that need to be ticked and things that you'll need to deliver as part of the curriculum. So we make sure all of our content is mapped to those curriculum as well. And then lastly, real world context. So everything we do, as I've already mentioned, we try to replicate models that you see in industry. So we want young people to leave school and to finish doing these courses and be able to put that into practice when they go into their future careers. We also want them to have the opportunity to engage and talk to industry at various points throughout our courses. So I'll go on to a bit more detail on how our courses offer that. So I mentioned pedagogy, and this is something that hopefully is more common, but when we probably first started out 10 or so years ago was less common. But we really like the young people to really take the lead in the kind of in any Apps for Good course. So when you think of maybe your standard computing suite with all the computers, hopefully not now, probably still all around the edge of the room, we want to see a classroom in a very different way. So students kind of working together in teams. Maybe they've only got one device per each group of students, and each team might be working at a slightly different pace to another in the classroom. And you as the teacher are very much kind of in the classroom, facilitating the sessions and making sure the students are okay, but leaving them to kind of reach their goal on their own. And then we also have our industry experts who I'll touch on in a bit more detail, but they're on hand to support at various points. But it is very much down to you as a teacher to deliver the kind of content and set the students in the right place. So our course options, obviously this session is around AI, so we're going to go into a lot more detail around our machine learning course, but you probably would have noticed our name is Apps for Good, so we do have courses around app development as well. So just a quick overview of the courses that we have available. So we have courses that cover timeframes of 10 hours through to 35 hours. Our kind of 10 to 12 hour sessions, courses are our most popular ones now. So our app development course that sees students work in teams to solve a problem that they care about by creating an app to solve that. We then have our machine learning course, which we'll go into a lot more detail on in a moment. And then we also have an Internet of Things course. And these are all courses that will be delivered either in the computing curriculum, or some schools will deliver these as extracurricular offers, so maybe lunchtimes, after school, or whatever kind of works for your school. But as I mentioned, they are mapped to the curriculum, so we feel they can be delivered within the computing curriculum and do fit nicely into that Key Stage 3. We then also have in a day courses. So these are day-long courses that we've created to kind of work with potentially like enrichment time, drop-down days, those kind of things. So if you have got any, maybe there's some days coming up even still before the summer where students are going to be off timetable, we have our day-long courses, and this essentially follows our same model but in a kind of compact way. So it's around 5 hours of delivery time. The students will start the day by kind of thinking about their problem and finish the day with a basic prototype, and we have those offers for both app development and for machine learning. So if you were to sign up to one of our courses, sign up's really simple on our website, and as a teacher you'd get access to all of the things that you see on the screen. So we offer some CPD, some training to make sure you feel comfortable to deliver the course, and you'll also get access to our schemes of works and the kind of curriculum links so that you can easily map that. We then have lesson primers and plans and objectives to make sure, again, you feel prepared to go into your lessons. Every different course will have a presentation for each session that you'll be able to run through with the students, and then the students have workbooks that they can work through individually as well, or as a team. There's also lots of videos, etc., that you'd get access to share with the students, so hopefully they find that engaging. All of the materials are available in every different format you could imagine, so whether that be to put them onto your Google Classroom or to download in kind of Microsoft, and whatever works for you, and they're fully adaptable as well. So we have lots of kind of detail there, but you can adapt them slightly depending on your students and your kind of audience. So industry experts, I've mentioned this a couple of times. As I said, that kind of real world link is something that's really important to us at Apps for Good. We really want to make sure young people get the opportunity to have a look and see kind of what it's like to work in a kind of tech or digital role and understand that, but also to get some real world experience and advice when they're creating their products. So there's kind of a number of different ways that we link industry to our schools, and luckily a lot of them are kind of virtual experiences, and that was the case pre-COVID, and obviously even more so as COVID kind of continues. But any school that's delivering one of our courses can request an industry expert for an expert session. In those sessions, we ask a school to give us maybe 2 weeks notice, and then you know, some details of the date, time, and what they're looking for, and we will then match that with one of our industry experts who will join the classroom remotely, maybe Skype, Hangout, Teams, whatever works for your school, and they will give the opportunity to the students to kind of pitch their product, and then they'll give some real life kind of advice and feedback on their ideas so far. So you can see a group of students here pitching to Alistair from Salesforce, and he's given them some feedback on their products. We work with, as I said, a whole range of corporate partners who fund us. So people would have industry experts from companies like Spotify, Lego, Bank of New York Mellon, Deutsche Bank, Salesforce, Google, you name it. We probably have some people from those industries signed up, which is great for the young people to be able to kind of interact with them. We then also have, this was predominantly pre-COVID, we've not really been able to do as many of these recently, but we have some potential kind of opportunities for workshops where we would go into the school to support the delivery of the course, and we'd also bring a number of volunteers with us for the day. So again, we might be working with for example, Spotify on a number of sessions. So we would have volunteers from Spotify come to the school with us and work with the students for the whole day. So really nice opportunity, again, to give them some real insight into industry and some valuable feedback from an industry perspective, but also an opportunity to really learn more about the career opportunities and see that full range of careers and why digital and tech skills and those employability skills are so important. And that is a big thing for us. Obviously, we very much do brand this as a kind of computing course, an opportunity for young people to really learn those tech skills, but it's not just about those tech skills. It really is about learning how they can work in a team, to solve problems, to communicate effectively, to feel confident when they're presenting and pitching their ideas. And then finally, we've most recently launched our expert feedback tool. So this was something that was actually created off the back of COVID, because although obviously virtual and video conferencing has been successful over that period of time, I know there was a lot of, you know, unfortunately, a lot of time when young people were working and learning from home, and for safeguarding reasons, it wasn't always the best idea to be able to have kind of industry experts join and have young people working at home. So we created our expert feedback tool, which instead allows students to just simply submit some of their written work, and we will then send that off to our panel of experts, and they will send some responses back to the students. So a really nice way for the students to get some real valuable insight from someone that isn't just their teacher, and actually kind of feel like they're being listened to by people in industry. And our industry experts absolutely love doing this as well. For them, it's a huge opportunity to see young people and kind of see how creative the young people are, maybe gives them some ideas to take back into their jobs as well. And we've had some really nice stories that have come out of our industry kind of interactions. So one example is we work with a school in Wick, up in Scotland, in the very northern part of Scotland, Wick High School, and they had an initial Skype session with one of our volunteers from Thomson Reuters at the time, and he was based in Atlanta, and he kind of had a few sessions with the school over Skype. He really took a liking to the school and really wanted to kind of be able to support them more. So the next time he was on a trip in London, he actually travelled all the way to Wick. I don't think he realised quite how far it was at the time, but he went up to the school to meet the students students in person to continue working with them on their products. And since then, there's been students from Wick High School that have been able to do work experience at Thomson Reuters, all based on that connection that was originally built. So yeah, for us, I think we really want to make sure that the career element comes through all of our courses as well, and young people are really thinking about what a career in digital and tech might be for them. And then each year, we've actually just come to the end of our awards for this year, but each year we have an annual competition where pre-COVID, we would have had a big fancy event in London. We've not been able to do that for the past couple of years, but we've still had kind of a way of celebrating all of the students' hard work. So student teams are invited to enter their products. We then have, this year we had over 300 shortlisters from all of our corporate companies reviewing all the entries, giving the students feedback on their ideas. Then we had 15 finalists and then 6 winners chosen. So if you're interested in learning more about the kind of ideas that the students come up with, then do have a look on our website. Some really cool ones this year. You'll get to meet our finalists and our winners and kind of get a bit of a better insight into the work they actually produce. And then just a couple of last slides on our impact, and then I'll hand over to Donna for a much deeper dive on our machine learning course. But in terms of outreach, so on average, we work with around 650 schools each academic year, reaching around 22,000 young people. For us, we work with every type of school and are really keen to work with schools that maybe are in more challenging circumstances or don't always have the opportunity to have access to programs like us. We also are really proud that each year we manage to reach around 50% girls when we look at our kind of gender breakdown of our students. Obviously that can be easier when you're looking at curriculum time, but even in our extracurricular club and seeing the teams that come through to the awards, we still see a really nice split in terms of girls and boys. And a lot of our teachers do tell us that courses like Apps Are Good are a really nice way to engage more girls into the world of computing and hopefully encourage them to go on to study that further. And then these are just some of the skills that our students tell us that they feel they've improved and that our teachers also reflect on. So at the end of each course, students and teachers are asked to kind of give some feedback, and we see reports on kind of improved skills around some of those things. I said problem solving, communication and presentation, most importantly as well, programming and coding skills, seeing improvement there, and then also looking at their career interest and the amount of students that come through and are more interested either working in the tech sector or a technical job, but then also more young people who are interested in potentially the more entrepreneurial route and kind of starting their own business and things like that. So hopefully that's what we hope any Apps Are Good course experience will kind of encourage all students to just think a bit differently about their future. So that's it for my slides. I'm now going to hand over to Donna to take over presenting. I don't know, Pete, if there are any questions or comments at this point whilst I'm handing over to Donna. If not, we can just do any questions at the end.
Yeah, hi Natty. Yeah, actually, there's just kind of, I guess that there's some comments. There's kind of one question that's come through, which is just, I think you might have answered some of it, but what are the 3 key things that you find the students kind of leave with following your kind of program of schools?
So I think probably the number one thing is learning how to kind of problem solve, and a bit of that resilience skills. I think it's something that we hear a lot back from our students and our teachers. Quite often within your standard world of education, you're taught not to fail, but indeed to succeed, and that failure is quite bad. So we often see that come through, I think, as something that students feel like they've really gained and had an opportunity to learn how to pivot, and if something doesn't quite work, to problem solve and try again. I think then definitely something that comes through really regularly from our young people is they feel like they've been listened to by someone who is important to them, and that is normally our industry expert. So they've had that chance to talk to someone they wouldn't normally get to talk to in their classroom, not devaluing the importance of teachers, but yeah, from their point of view, they've had a chance to speak to someone who's exciting, who works in industry. And then I think definitely the digital skills, we definitely see a huge improvement, particularly from students who maybe just didn't engage with computing as a subject. They didn't think it was for them, but they now feel it's more relevant to them, and they can see that how they associate with it, and just understanding the wide range of skills, putting 2 and 2 together and understanding that design is actually very closely linked to digital and tech. And yeah, that, I mean, it's hard to pick just 3, but probably those things are what I think come through.
Brilliant, thanks Natty. Yeah, no, that's great. I'll hand back over to Donna to take us forward.
Okay, thank you. Right, so as Natalie said, I'm going to take you onto a sort of a deeper dive into our machine learning course and just explain some of the sort of principles behind it and some of the different activities that the students are engaged with. This is the student journey, split really into sort of three parts. The knowledge building one, for any of you who have done our app development courses, there's a lot more that needs doing in terms of knowledge building when it comes to machine learning. I would say both the students and for the teachers, and I speak as an ex-teacher myself who's had to sort of get up to speed on some of this. The applying side is our standard methodology. So as Natalie was saying, we're looking at spotting problems that they want to solve. We're developing a prototype, a model, having that expert session to get some feedback on it, building and testing then the working prototype, and then you can enter the awards or have sort of pitching sessions. There's also a couple of extra sessions which may or may not be as applicable for your students. I would say probably at least Key Stage 4 if you want to have a look at these. So one is on algorithms, so that's very mathematical. It's looking at different sort of models that you can use for machine learning and having some sort of practice on using those different algorithms. And then there's one which is just a bit of an introduction to Python programming. So looking at how you can use libraries and a bit on sort of data representation, data visualization in those. So for the main building part then, these are some of the things that we're going to be having a look at on sort of the next few slides. So just a quick sort of update, just sort of we're all talking about sort of the same definition of machine learning. So it's rather than programming step by step, you are giving the program a whole load of data for it to analyze. Now, sometimes we'll label that data so it knows what it's looking at and then can learn from that. And sometimes we leave the computer to actually identify patterns of its own. And the reason that we're going to be doing this is there are going to be some of your students who will want to go on and have a career in tech and who will want to be sort of really having a good sort of deep dive. But I think it's important for all students. It's so prevalent now having sort of machine learning working in the background for so many different things that we're interacting with, whether that's your Siri or your Alexa, or whether that's things like Netflix or Spotify giving you different recommendations. There's lots of different ways that you're going to be interacting. So I think it's really important for all students to really understand what's happening in terms of that technology. So we start off very gently. This is a really nice, quick activity, though it can be difficult getting the students off it afterwards because they really enjoy doing it. Quick Draw, which is, I think, one of the Google apps. It gives you 6 prompts for things to draw. So there's my very weird picture of a tree. And it learns from each person that uses the application. So it'll get more and more people's versions of what a tree looks like, and it gets better and better at identifying the drawings that you're doing. So it'll give you like a score, and then it will show you all the other different drawings that other people have made. So you can see how it's building up that knowledge of what those images are. Now we take that idea a little further and just get the students then to think about themselves. I've got 2 images there. I can quite clearly see that one's a cat and one's a dog, but if I was trying to program a computer to do that, how would that do it? So getting to think of some rules. How could you identify what the difference is between those 2 images? And once they've got that set of rules, give them some more images. Do those images conform to those rules that they've got as well? And if not, why not? And hopefully from this activity, they can start to see how complex it is trying to do something as a computer that you just see automatically, that you learn, you know which of those are cats, you know which of those are dogs. And then we've got a range of different tools that we can use. So following on from this, we use something called cognimates. All of these tools that we use in the course are free, and they're all internet based, so there's nothing that you need to have downloading on these. So Cognimate allows you to drag and drop a whole series of images. So you're creating 2 labels here. It happens to be cat and dog. It could be anything you like. So we drag these on from Google Images, and then we show it something that it hasn't seen before and get it to see whether it can identify. So in this particular activity here, it's correctly identified that it's a dog, and it's 99.94% sure that it's correct. Now, for some of them, it may be sort of far less, and that leads into discussion about what's the algorithm using to try and decide between the images and put them into specific categories. Leading on from that, another nice free activity, Teachable Machine. Now, this version of it uses your webcam. If your webcams are disabled, there are alternative ways of using this this tool, which don't require you to have the webcam on. But basically, it's looking at gestures. So I can put up a hand, I record myself putting up a hand, and then it's learned that that's me putting up a hand, and it will put either a picture or it will put a message up depending on what I've actually asked it to do along here. I can then do a different gesture here and then a third, and depending on which gesture I'm doing, it should be able to identify, and it will change the picture or it will change the message that it's giving out. There's versions of this which allow you to do the drag and drop as we've done before, and there's also a sound one, so you can start seeing how Siri and other voice activated AI is working. Following on from that then, we've had a look at how we're identifying images. What we're trying to do with a lot of these activities is have examples that are going to be sort of relevant to the students. So this activity came from a news report that was on sort of last year, which was about Instagram trying to filter the messages that people were putting up. It wasn't going to block them, but it was going to put up a prompt and say, are you sure you want to put that up? Really to try and iron out sort of inadvertence of bullying or upsetting people. And we look at how we can build a prototype of this. And for this one, we're using machine learning for kids. Again, another free online tool that you can use. And what this will allow you to do is, just in the same way as Cognimate, you're going to set up 2 or more different categories and then give it examples of what will go into that category. So if I'm having some kind things, I'm going to say, I like you, you're so clever, I like you, I love your outfit. Whatever you want to put in there, and then mean things. So your hair looks terrible, what an idiot. So things that people might get sort of upset by. And it will use that data and it will produce blocks that you can then export out to Scratch. And once you've got them in Scratch, you can then use them in your programs, so you can start building an interface for your model. So this one here will have a smiley face if you say something nice, and it will have a sad face if you say something so that's not nice. And you can then refine this further so that if they're not sure, if that confidence percentage is below a certain threshold, it might just have a sort of a neutral face going, I'm not sure I understand, or I don't know what you're saying. So it's a way of students then being able to use this tool to think about how they could develop it further in solving a problem that they were interested in. We've had quite a lot of sort of particularly nice sort of chatbots and things coming out of this. Again, trying to make sure that we've got things that are going to be relevant for the students. We have a look at recommendation systems. There's quite a lot of videos in this course, really to make sure that they've got really clear examples and explanations of some of the concepts that we're trying to get across. So we have a look at Netflix, about why you get those recommendations that you do. And similarly, the Spotify ones, and the look about how does that Discover Weekly come about, what's the science behind it, how does it actually go about producing that. So that's lots of different examples of how we're using machine learning. But one of the key points, I think, and one of the real sort of selling points of why we need to be teaching machine learning is those ethical considerations. It's becoming involved in so many different things. You need to understand what's going on under the hood. So we look at things like the bias in the training data. So it's a sort of well-recognised fact that facial recognition software is a far lower success rate if you are BMAE users than it is if you are white, and similarly better for males than it is for females. Looking at some of the dangers behind those recommendation systems. So filter bubbles is one of them, but also being exposed to more and more extreme content. So you start looking at something on YouTube, and before you know it, you're into sort of deeper and deeper. It might start with vegetarianism, end up with sort of, I don't know, animal experimentation, sort of saboteurs or whatever. But whatever the topic, it has to keep trying to keep you on there. So it gives you more and more extreme content. And also the use of targeting for advertising purposes and how they're used in sort of political influencing as well. A couple of examples of the bias of machine learning. So this one here, they tried to sort of automate the CVs and make this so they wouldn't be so biased. So they fed in a whole load of CVs of successful candidates and asked the machine learning model to then decide whether somebody was likely to be successful. But obviously what it did do was it sort of replicated what it was being fed. So if most of the people that had been recruited were male, it would be looking for any clues that it might be a female in this. So if we mention women's colleges or sports or organisations, then they were more likely to be rejected. So an unintended consequence of trying to sort of remove bias. Similarly in the justice system, so there are models now available to start thinking about whether somebody should have a custodial sentence or whether to have a community sort of sentence instead. And again, what we're seeing, because they're feeding in previous information, if the data that it's receiving is biased, then the results coming out of it are going to be biased. And then one that will probably resonate very much with students is last year's A-level grades being downgraded, again, because of the algorithm that was behind it. Now, in that particular case, the algorithm was a statistical model rather than a machine learning model. But that's not that comforting. At least with the statistical model, we knew how it was working. So it was relatively straightforward in working out how to correct it. One of the problems that you've got with machine learning is some of these algorithms, they don't know how it's working. They're feeding in all of this data, it's analysing, finding patterns, coming up with answers, but nobody really knows what's going on in the middle of that. Self-driving cars is another really interesting one to have a look at. Moral Machine from MIT gives you a whole load of different scenarios, and you have to decide whether the car is going to go straight on or whether it's going to go into the barrier and risk killing the people that are in the car. What it's looking at here is all of these different factors. So the students do this activity individually, and then they come together with this as a card sort, maybe sort of a diamond or whatever. So which ones are important? Which ones should we be sort of prioritising when we're building these sort of models? But then taking it a stage further. Is it morally or ethically right to pre-program those decisions? If you're there and it's a spur of the moment and you're trying to react, then you do the best you can within that circumstance. But if we're saying 6 months in advance, we're going to be programming these sort of decisions. That's a whole new ethical sort of dilemma that you've got. And the final one within this is if we're actually coming to buying one of these cars, which one are you going to buy? Are you going to buy the one that's going to protect the most number of people, or are you going to buy the one that's going to protect you as the driver? And we have sort of a little quiz that students can get involved with to see what they think they would do in that circumstance. Finally, we have a look at the impact on employment. As more and more things become automated, more jobs are going to disappear, and what we're looking at is what's going to happen in the future if that is the case. This is quite a famous sort of little quote just about, this was about robots, but the same can apply to sort of machine learning and artificial intelligence. You know, if we've got lots and lots of people who are out of jobs, who's going to buy the things that are being produced? And this one from the BBC allows students to analyse different jobs and to see how likely it is that it's going to be become sort of replaced by machine learning. So some that you might not think of become ones that could actually be sort of automated in this way. And I suppose really what we're looking at here, I think this quote here, I think probably sort of sums up part of the ethos, particularly the second part, is that by thinking about how you program machine learning, you're thinking about really about what we are doing. I think it exposes quite a lot of sort of biases and assumptions and things that we never really think about until you have to be thinking about what that consequence would be if you are having that replaced by machine learning. And then I think a final one for all of our students is what we need is a lot more diversity within those environments where machine learning is being developed in order to be able to reflect the people that are actually going to be using it. And then just a couple of things here, just as a final thing, is just looking at a couple of ones that we've had to do from students before. Now, this one was actually analysing how people brush their teeth. And then based on that analysis, is then giving sort of suggestions and feedback on how they can improve their oral hygiene. And this one here, the AI noise sensor, was analysing different noises and noise pollution and looking at how they can reduce that depending on what the source of that noise was. And that, I think, is a very quick sort of overview. But any questions?
Hi, Donna. Thank you for that. That was absolutely brilliant. I actually don't have any specific questions that have come through, but I have got lots of comments about the resources and the range of resources that you've shown and how various people are going to go and check them out. So I think you know, that's really nice just to see those wonderful sort of applications you can use in the classroom. Yeah, I found it really, really enjoyable. Thank you. Thank you for that. But I don't have any more specific questions. So I guess, Natty, is there anything else you wanted to add in, or are you all okay?
No, I don't think so. Just to say, yeah, if anyone is interested and wants to learn more, like, feel free to get in touch. You'll find us on Twitter, or you can email us at education@appsforgood.org. But yeah, signing up is really simple. You can already go online and see some of the resources in more detail before you sign up. And as I said, it's totally free of charge for schools. Yeah, so I think just get in touch if any questions, and yeah, have a look at the resources.
Great, thank you. So just to let you know, when you close down this webinar, you'll see a short survey that will appear at the end. And if you could just take a few moments just to complete that survey with some of your thoughts and you know, reflect on some of the wonderful opportunities and experiences that have been shared with you today. A recording of the webinar will be available, so if you want to, if you came a little bit later or you want to watch it through again, then that'll be available on the CAS YouTube channel sometime soon. And just to let you know that although this is coming up as kind of day 8 of the CAS Virtual Showcase tomorrow, and there are 2 sessions I want to draw your attention to tomorrow. The first one is podcasting to deliver cross-curricular topics with James Gerald, and also at the same time is moving homework online, and that's with Will Franklin and Suzanne Craig. So just a final thank you to our wonderful presenters today, Donna and Natalie, and I wish you all a wonderful evening, and you can now go and also you're ready and you can enjoy the football. Thank you very much.
Thank you.
Thank you. Bye.